Now let's take a look at chooser options. So basically, a chooser options is an option where at maturity, that option becomes either a call or put. So, and obviously, um, if they're not in the money at the same time, or if one it has a positive payoff, the other one has a negative payoff, so always the one has a positive payoff. That's the real payoff. So for simple ones, where we're talking about where both the underlying ones, which is either a call or put, they're both European and they have the same time to maturity and the same strike price, then we can use a put-call parity condition to price the chooser option. Now, if the case is not that simple, the time to maturity of the call and the put, or the strikes of the call and the put are different, then we can still price it. We'll use we'll go through an integration, like what we have seen earlier for the compound options. And through that, we can still price them. Here, we need to notice that the chooser option doesn't really have a strike price, because what a chooser option is that at maturity will become, one of the two possible options. So you don't really, you will always become something. And the question is whether it becomes a call with a given strike and maturity, or it will become a put with a given strike and maturity. But there'll be no chance that the chooser option will, and matured, will have a value of 0, because it will become an option, and that option will always have some positive value. So let's now determine the formula for the simple case where we have a chooser option become either call or put, and the call and the put are European options with the same time to maturity and strike price. And let's use put-call parity condition to price them. So just first of all, some notations. We're at some time 0, and the maturity time of the chooser option is T1. And but once we exercise at maturity T1, we get an option either the call or the put. But the call and the put themselves, they have a maturity at T2, okay? And T2 is greater than T1. And the call and the put have the same strike price K. So how do we value that chooser option? Well, if you look at it, the payoff function of chooser option is really max, call, or put. And okay, let's take the case where we can express a put through a put-call parity condition. So then the payoff function becomes the max of a call, where the put is actually expressed as a put-call parity condition like this. Okay, so become a call plus this part here, which is the discounted value of this K minus this S times this, okay? Now this is S1 because it's the realized price at T1. Now, if we rearrange, then we bring this in, we'll see that this max function is really just the call plus a e to the power of minus q times this time difference of max 0, or this thing here. So this thing is what? It's really like a put payoff, right? So really what we have here, we have turned this payoff function into this thing, which means that our chooser option is nothing more than a regular call, which is this thing here, with the strike K and maturity T2. And this many unit, which is this thing here, this many unit of, this is like a factor. So this many unit of regular put option, where the put option, the strike price is not K, but K times e to the power of this thing here. And maturity is T1. Okay, so we have turned a simple chooser option into a component of, or portfolio of two options. One is a regular call with strike K and maturity T2, and this number of unit of put option with this particular strike and maturity time T2. Okay, because we know all those parameters, then we can simply plug in and use the Black-Scholes formula to calculate the chooser option. Now here we have chosen to express the put in the put call parity condition. We can do exactly the same by keeping the put here, but express this call differently using the put call parity condition. So there will be a put somewhere here and plus a whole bunch of things. Okay. Now if we do that by expressing the put, by expressing the call in this, then we can rearrange. Then basically a chooser option becomes a regular put with a strike price K and maturity T2. And this number of unit of call with a strike price of this thing and maturity T1. Okay. Now, since we are either way is okay, you should be able to demonstrate that this portfolio has the same value as this portfolio. Okay, because there are equivalent ways of pricing the same chooser option, and they must have the same value. Let's now take a look at some example. Let's take an example. Suppose we have a chooser option with 3 months maturity, and it's written on the stock that pays 1% dividend, and has a volatility of 30% per annum. Okay, that stock is currently traded at $100. So the chooser option, then a maturity will become either another call or another put. So if for the once it's exercised at maturity 3 months later, the put or the call will have 1 year maturity and a strike price of $110. Okay, so the risk-free rate is basically say flat at 2%. That means the annual rate doesn't matter which turn, is always 2%. Then we can price the chooser option based on the formula we had just described. So in this condition, then T1 is 3 months, which means 0.25 year, and T2 is 1 year and plus 3 months, so 1.25. Sigma is 30%. Current stock price is 100. Strike price is 110. Risk-free rate is 2%. Dividend yield is 1%. Okay, so the call with the strike price of 110 and T2 maturity has a price of $9.87. And the put with this strike price is then, because this is the adjusted strike price, and T1 has a price of $11.45. So this many of unit of the put then has a value of $11.34. So when we put them together, it's basically this regular call plus this many unit of the put, which gives us this sum here. So the true option itself is worth $21.21.